talk about unit conversion. So unit conversion is just a matter about multiplying fractions. So if I have 5 centimeters, I recognize I'm not going to worry about significant digits here. Actually, no, I will. Sorry, scratch that. So if I have 5 centimeters and I want to convert to meters, well, I'm going to multiply by some fraction that's equal to 1, because the math people tell me if I multiply by 1, so if I take any number times 1, I'm going to get that same number back. This 1 right here, so I'm good as long as this number right here is 1. And it's a fraction, so as long as the top and bottom are equal to each other, that's good. So 4 over 4 is equal to 1. I know you're well beyond this, or most likely you were well beyond this, but I'm emphasizing a point here. So if I did 4 over 4, that's 1. If I did 4 over 1 plus 3, that's also equal to 1, because the numerator and the denominator are equal to each other. Therefore, my fraction is equal to 1. So what I'm going to be doing here is I'm going to create a fraction where the top and bottom are equal to each other. So I'm going to put 1 centimeter on the bottom, and I'm going to put 0.01 meters on top. They are equal to each other. So this is 0.05 meters. I could have I have 5 centimeters here. I could have also done 100 centimeters on the bottom and 1 meter on top, and I still get 0.05 meters. Now, when you're trying to figure out how to write the fraction, and some people struggle with this, if I have 4/3 times 3/2, well, when you're multiplying fractions, you multiply the numerators, and you can multiply the denominators, and you get 2. But the shortcut is you can cancel things out before you get there. I have a 3 and a 3, so I can cancel those out, and technically a 1 is left behind, even though we usually don't write that. 2 goes into 4 twice. And so what I end up with is 2 in the numerator, 1 in the denominator, which is just 2. So I can cancel things out before I get there, as long as they're common factors. Writing this out a little bit more explicitly here, if I have 4 over 3 times 3 over 2, recognize that 4, if I break it down to the base factors, I'm forgetting the wording right now, that's 2 times 2 over 3 times 3 over 2, and that 2 cancels out with that 2, that 3 cancels out with that 3, and what I'm left with is 2 over 1, which is 2. Remember, when you cancel factors out, a 1 is left behind. Let's do one more. If I have 12/5 times 30/4, well, 4 goes into 12 3 times, 5 goes into 30 6 times, and I'm left with 18 over 1, or just 18. Well, the same thing's happening here. I can take anything and always make it a fraction. I can make anything a fraction just by putting it over 1. And so now I can get rid of common factors here. I have centimeters and I have centimeters. They would cancel out. As long as one's on top, one's on the bottom, they're going to cancel out. So if I'd flipped it the other way, I couldn't have canceled the centimeters out. So since I want to get rid of centimeters, centimeters goes on the bottom. Same thing here too. I don't have to write the over 1, but that's just a visual, just indicating we're doing the same thing here as we did here. So if I have 5 meters and I want to convert that into feet, let's make it 5.372 meters, and I would convert that into feet. So now let's deal with significant digits. So I have 5.372 meters times, well, I know a conversion here of centimeters. 2.54 centimeters equals 1 inch. I know 12 inches is equal to 1 foot. I know 100 centimeters is equal to 1 meter, and that's all I really need to know in order to get there. I'm going to go from meters to centimeters, centimeters to inches, inches to feet. So I multiply here. So I want to get rid of meters, so meters goes on the bottom, put 100 centimeters up top. And then, so my meters are going to go away. Again, that's over 1. And let me put that in red to emphasize that. I'm just tacking that on after the fact. Centimeters to inches, I want to get rid of centimeters, so I need centimeters on the bottom because it's on top right there. I'll put 2.54 centimeters, 1 inch. The centimeters will go away. Now I have inches to feet, so times 12 inches, 1 foot. And so all my units have canceled out except for feet. And so now it's just a matter of multiplying it out. And also show off the nifty calculator here. So type in 5.372, enter, 100 times 2.54 divided by 12 divided by, and I'm left with 17.6246711916 feet. Now, not all of it is significant, so the question is, where do I round off? Well, these right here are all exact. It's exactly 100 centimeters in a meter. It's exactly 2.54 centimeters in an inch, exactly 12 inches in a foot. And by the way, why is it 2.54? Because that's what the powers of be said so. At some point, the group of people got together and they said, we are going to establish that as fact. So therefore, since these have all infinite significance, this is the limiting factor. I have 4 significant figures here, so I have 4 significant figures here. So 17.6, I round off at that point, 62 feet. Now, there are some people who do the grid, so 5.372 meters, and they set up this grid of 100 centimeters per meter, 1 inch per centimeter, and 1 foot for 12 inches. 1 inch for 2.54 centimeters and 12 inches. I'm not as big a fan of this style, and there's nothing legitimately wrong with it, but to me, what we're doing here is we're multiplying by 1. We have some number here. I multiply times 1, multiply times 1, multiply times 1. So these two are equal to each other because all I did was multiply by 1. This, I think, sort of de-emphasizes the fact that all we're doing is multiplying by 1. If you do this, if this is what you're taught, go for it. If you have no idea what I'm talking about, don't worry about it. People do have issues in doing unit conversions is the squared and cubed terms. So if this was 5.372 meters cubed, or cubic meters, and I want to convert into cubic centimeters, recognize that I have 3 units I am converting here. This is meters times meters times meters. I need to convert each one of them. So this would be 5.372 meters times meters times meters times 100 centimeters per meter times, so that'll take care of one of them, 100 centimeters per meter, that'll take care of another one, times 100 centimeters per meter, that'll take care of the third one. So this will end up being 5.372,000 cubic centimeters. I could have written it slightly differently. So 5.372 cubic meters. If I know I'm going to I have 3 meters that I need to convert, well, then I could just do 100 centimeters per meter cubed. And recognize I'm cubing the top and I'm cubing the bottom, so that 100 also gets cubed. And so this becomes 5.372 times 100 cubed centimeters cubed, because the meters cubed would cancel out with all those. And so that's 5.372, 1, 2, 3, 4, 5, 6. Move it over 6 places. These are trailing zeros to the left of the decimal place, and therefore they are not significant, so we still have the same number of significant digits. Another way of looking at that, if I have a square here, let's make it a rectangle, and this is 3.2 meters by 2.4 meters, then my area of my cube is length times width, so my area is 3.2 meters times 2.4 meters, 7.68 meters squared, because I have meters times meters. If I did this in centimeters, if I wanted how many square centimeters is it? Well, there are two ways of doing it. I have 7.68 meters squared times 100 centimeters per meter squared. Notice I'm not writing the number here. I didn't write the number there. It's understood to be a 1 there. So this would end up being 76800 centimeters squared. Now, because I'm multiplying here, these have each 2 significant digits. This has infinite number of significant digits because this is an exact conversion here. So my final answer needs 2, and so 77,000 square centimeters is my final answer. Or I could have converted first, and so this is 320 centimeters by 240 centimeters. So if I multiply 320 centimeters by 240 centimeters, I end up with 76800 centimeters squared, because I'm multiplying centimeter times centimeter, so I get centimeter squared. This has 2 sig figs, this has 2 sig figs. These are trailing zeros to the left of the decimal place, and so we end up with 77,000 square centimeters. And I guess one other note while I'm here, I put a comma on the decimal point. If those who have been educated in the US, absolutely no problem. Don't worry about this next bit. For those who have been educated under a European system, recognize that in the US, and presumably you know at this point, but in the US we flip from what you consider as the comma and the decimal point. It's led into one strange problem, is that when I was doing IT consulting, people would put in a request to have certain values changed in the system, and at that point in my career, I was one of the people who would change it. Now, sometimes we'd be getting requests in from Europe, and they knew an American was doing it, and so they would translate it. So if they wanted the number to be 2.5, you might see the request from Europe as in 2.5, like written like that. Or they might go, oh, they're Americans doing it, so let me translate it into that number right there. And so you see that and you go, okay, it's 2.5. You see that and you know, well, that's not the thousands place mark. And so that's also 2.5, and you do the conversion in your head, or the translation in your head. But I did get a request in where somebody put in a request of they wanted the number to be 1000, and the request came in from Spain, and I did not know whether they meant that to be 1 with 4 significant digits, or was this 1000 with 1 significant digit? And considering the time differences, it took a couple days for that to eventually get resolved. So, but just recognize I'm using US system here. So these are the separation from between the 1s and 10th spot. And I use the comma for the thousands separator. Thousands, millions, the orders of 1,000. The orders 10 to the 3rd, 10 to the 6th, 10 to the 9th, and so on. Separator. And one other thing, and this is just, it's, after a while it gets tiring, but separation and separator, a rat shows up in them. Separate, a rat shows up in separate as well. This is not an E, it's an A. All right.